Hello everyone, I'm Jianxin Sun from the Institute of Automation, Chinese Academy of Science. The theme of my presentation is AnyFace, freestyle test face synthesis and manipulation. Existing test descriptions for image synthesis and manipulation are only limited to a freestyle. For example, fixed number of sentences, formatted grammar, and existing words in the train set, severely limiting the user's creativity and imagination. This paper aims to explore the first plausible solution for freestyle test face synthesis with successful applications on face image synthesis and manipulation. We can see that our method supports any number, any format, and any content or captions. The train stage is composed of two streams. Face image synthesis stream is responsible for generating a face image given the input text, while the face image reconstruction stream performs face image reconstruction and provides visual information for the face synthesis network. The cross-modal distillation model is used to realize the interaction of linguistic and visual information, which is composed with several transform and linear layers. The latent codes are projected by the CMD model and concatenated with the content code as input to a stereogram decoder to synthesize the results. At the input stage, we only keep the face image synthesis stream. For test-guided face manipulation, the content code is replaced by the latent code of source image. The two streams are trained with different objective functions. The face image synthesis stream contains a downward triple loss to project the test feathers into stereogram latent space, a cross-mode transfer loss for distillation between two streams, and a clip loss to ensure semantic consistency between the generated image and the input text. The face image reconstruction loss contains a cross-mode transfer loss, an MC loss, and a reconstruction loss to reconstruct the face image. It's worth mentioning that we design a downward triple loss instead of using pairwise loss, which effectively resolves the mode collapse and increases the diversity of results. We compare our AnyFace with previous state-of-art methods on Cerebral A test EQ and the multimodal Cerebral HQ dataset. AnyFace outperforms the current best methods with an impressive improvement on both datasets. We can see that compared with previous methods that can only synthesize low-quality results and irrelevant faces, the images synthesized by our method are much better in terms of image quality and semantic consistency. Benefiting from the powerful representation of clip, test declarations with similar meanings will be encoded into similar latent codes of stereogram even though the test declarations contains abstract information. Overall, AnyFace learns visual concepts from test descriptions. Our method can also synthesize images with any number of captions. Compared with CT to F, the results of AnyFace are more consistent with the text and show natural and smooth appearance. AnyFace can also be easily adapted to manipulate face images continuously given the test declaration by changing the size of text embedding. As test information increases, the generated face will be more consistent with the test information. In this part, where we conduct application studies to evaluate the contributions of downward triple loss and cross-modal transfer loss to our framework, we can see AnyFace with downward triple loss produces diverse and personalized characteristics, while cross-modal transfer loss can produce some stratified feathers and speed up convergence of training. Overall, to the best of our knowledge, AnyFace is the first definition, solution, and application of freestyle test face problem, which is a breakthrough to remove the constraints in face image synthesis. Another two-stream framework is proposed for accurate and high-fidelity test face synthesis and manipulation. Our method provides a good fusion solution of clip visual concepts learning and stereogram high-quality image generation. Our work will definitely inspire more creative and wide applications of test-to-face technology. Thanks for your listening. Does anyone have Any questions or suggestions?